So there's, I've been, I guess, teaching building simulation for the best part of 15 odd years. So I've got a couple of lectures that are quite useful for those of you who want to start and would like to kind of understand what energy simulation is all about. Now, I'll put the link of this particular session or this particular lecture that you can find on YouTube. It's really the first lecture that I do for any class on energy simulation that I take. And it's useful because then we are all on the same page as to what exactly energy simulation is. And I would encourage you all to go and have a look at it in some detail. I'll just shoot through a few of the slides now, just to get us sort of going. But it would be really, I believe, useful for all of you if you wanted to go back and have a look at the full lecture. So what we do, let me just get my presentation mode up here, is the thing that I'm interested in looking at is what exactly is simulation from the point of view of people who have not used it before, right? And there's a slide that in the session that I keep coming back to, and it's this slide here, right? So typically what I say is that for an energy simulation model, you're building the geometry, you are defining the materials of the building that what it's built with, constructed with. It's quite important for you to understand what the glazing systems or the window systems are all about. And typically there are people who spend their careers selecting glass products and frames so that the combination has a particular performance requirement. Then there's a series of internal loads that most air conditioning engineers are interested in. And that has to do with solar radiation through the windows, or internal heat generation due to lights and people and occupants. And then we talk about ventilation, that which you put in and you want, and that which leaks because of the quality of construction of your building. Okay. Once you put these inputs in, then you make a guesstimate of how the building works. So typically you provide a schedule or a profile of how these loads vary compared to the design load. So a design load for occupancy might be 10 meters squared per person, but across the year, across the days, on weekends and weekdays, you may have different times when you assume people come in, or how many people come in as a percentage of the design. Similarly, for lighting systems, any plug loads that are connected to the building, infiltration rates, and many other things. Okay, but you need to let the model know how the building is being operated, because you are looking at the heat flow and sometimes heat and mass flow for 8,760 hours of the year. Then finally, you need to describe systems in the building, and these are usually lighting systems, air conditioning systems. These are the, particularly air conditioning systems are climate dependent systems. You have other systems miscellaneous exhaust fans, lifts, lighting, which may or may not be climate dependent. Generally, they're not. Hydraulic pumps, if there are any in the building, so on and so forth. Okay. So, and that lecture, I sort of cover that in some detail, and I think it's probably worth you going through that to sort of get an understanding of that. Now, I believe all of you have already downloaded Design Builder. So I think the easiest thing for us is to actually do some activity on that. I will, in that link that I sent through the chat a little bit earlier, in the folder, that Dropbox folder, there is a DXF file, which I'm hoping all of you have already downloaded. Can somebody send me a chat message saying that they've successfully managed to download that file? Anyone? I just want to know that you've got access to that file. Hello? I can see Josh has just sent that link again.
The link is accessible.
It's accessible? Good. All right. So if you can download particularly the two PDFs and this DXF file, we're going to work on that right now. Okay. So what I've done is I've opened up Design Builder, and my opening screen looks a bit like this. And what I'm going to do is I'm going to open a new file. So there you are. Now you may have some other location here. You can choose a location, and to do that, if you click once, you will get these three dots. You can double click on that, and basically you simply navigate to the country of your choice, which at this point I think is going to be India. And you've got a few files, locations here. Pick one. I've got Bangalore here. You can pick any one you like. And what we'll then do is just click on the OK, and it starts to go away and set up a new file. Now, some of you might have already tried this out. Some of you may not have, but let's do this. And when it opens up, or while it's opening up, you can see that your Design Builder screen has got three sections. The section on the left is a middle section, which is a drawing section. And since we are on what's called learning mode, there is a tab on the right, or a section on the right, which always tries to give you some tips on how you can proceed. So once we are here, we're going to import that DXF file to have as a background, and then we'll use that to draw the building. Okay, and that might be something that you might want to do. You can do it using bitmaps and DXF files, and DXF files are really quite accurate. You can do 3D Revit type export, but what we found in our office is that's sometimes less accurate, and probably sometimes there's less confidence in the model, because you bring in a very huge model, and if you miss something, you can't say what's going on. So I'll do a file. There's an import function here, and you import a 2D drawing file. I'm going to navigate to that folder, which I shared with you all. So let me navigate to that. And in there, there's this DXF file. I'm going to click on open. And the thing that you've got to be very careful about is what units was that CAD file drawn in. Okay, in this one, it's millimeters. Press next, it'll give you layers. And if you've got a really complex DXF file, you can switch off layers that are not useful. Gives you a rough idea of what is the size of the area that you are importing. Okay. Now, in this case, if it was 6.3 meters or 8.5 meters, I know the scale is wrong. Similarly, if it was 6,300 meters, then again, I know the scale is not correct. Okay. So if I finish, then I can see the background of my building. Okay. Now it's pretty simple. We decide to add a block, but before I do that, I just want to show you that the building I'm interested in is this L-shaped building, but it's this middle line that I'm going to be drawing, not this outer line here. And we'll see that as we proceed. So let me add a building. And at the present, I'm just going to accept defaults. As you get more and more expert, you can start looking for other options. Again, because I'm using Zoom, it takes up a little bit of the bandwidth, so it's a bit slow at this point. But once it sets up, we should get a pencil with the 3 axes, and that allows us to do the drawing. Okay. So what I'm hoping to do in the first hour is to quickly draw 1 floor building and do a quick simulation, show you where the results all are, and give you some options on how you can review the results. And then we can see all the different capabilities that Design Builder have. Obviously, we won't be able to cover a lot, but at least if I can get you guys started and you can start looking at the help files, then it'll be a good place to start. So I'm just going to move this to the middle of the screen. There's my pan tool. If I press escape once, I'm out of pan, back in the pencil mode. You can go clockwise or anti-clockwise, just stay in one direction. So if I use this corner, and you can see that with a DXF, it will snap to all the corners. So it's pretty easy. And the thing that I could have changed is what's the height of this block. So at this point, it's 3.5 meters. And you can see that there is a building up. Okay, and the building's got some default windows. It's got some default constructions, and we call this a kind of garbage in, garbage out model, because I don't know what I've got there. I don't know any of the inputs clearly unless I've set up the default numbers. Okay. So at this point, actually, Design Builder is, and I'm going to press escape to come out of the drawing mode. So at this point, Design Builder, this file is actually ready to run a simulation. Okay. And there is a data tree that is now building up on this left-hand section. So the top one, the thing that says untitled, I can change the name. That's your location. So I'm going to call that Bangalore because that's what I've got. This is building level. This is below that, the block level. And if I click on that, I can see what's inside the block. And inside the block, there is one zone. If I go to this zone level, then I can see what's there. I can open up that zone level, and these are all the components that make up the zone. So there's a ground floor, there's a roof, bunch of walls. If I open up any of the walls, you can see there's a set of windows there. Okay, and I can navigate to any one of these items. Okay, so by just clicking on there, it will move you to that particular item. Okay, now when you think about what we call a block level, you can think about that being like a floor level, or if you had an atrium, the whole of the atrium could be one zone. Ground floor car park could be one zone, whatever. There's a so if you kind of remember that you are sort of coming from location to building to block to zone, and then from the zone you can see that you're going to surfaces, and on the surfaces you can see you're getting to a subsurface type level, and these are important as we navigate through design builder. So now what I can do is, if I look at this zone, give me a second here, I'm just going to make that display a little bit bigger. So I'm changing the label size to large. Yeah, now I can see this zone 1 large and clear. Okay. Now, if I look at this flow plate, it's like a, okay, let me put it in plan view. Yeah. It's like a fairly large open flow plate office, but you've got these unconditioned zones, plant room, lift shafts, toilets, and I'm not going to be conditioning that. So what I'll do is I'll separate this out into a zone. And the way Design Builder works, you can have a physical wall which separates things into zones, and that's over here. If I do a partition and I use this standard partition and I draw this one set of walls, then that's a physical wall in gray, and suddenly I now have 2 zones. Okay, and zone 1 is my unconditioned zone. So if I call this ground floor, sorry, I can rename it, which is what I'm doing now. So I'll call it ground floor, and I'll call it unconditioned. Okay. I've immediately broken up that block into 2 thermal zones. Now, if you're interested in air conditioning, typically an air conditioning engineer will split a floor into perimeter zones that are next to the external wall, and a center zone or an internal zone, which is not connected to any of the external walls. And there's a reasoning for that. If you can condition them with separate systems, you can maintain comfort in each of the zones. If you don't separate them into perimeter and center zones, then when you do a load calculation, it's a really big average across the flow plate, and everybody's uncomfortable at all times. Okay. Why do I say that? Well, if I go into building level here, put into visualize, do a render view, okay, turn on sun path and shadows, okay, and I'm going to make this the 21st day for both the day of the month and for the sun path diagram and for the day that I'm going to analyze. What it does is it just reduces the number of lines in the sun path, but now you can see how it is. Okay. Now, if you look at the sun path, you can see that in India, the sun rises in the east, but it comes around on the southern part of the sky, okay, which is why you see that the line is inclined to the south. Okay. Now, if you look at, say, a morning time, 9 o'clock in the morning, okay, the sun's coming from there, right? If I take a section, take the roof off, and just have a look, put it into plan, then you can see that from the east in the morning, the sun comes in this way, okay? And you can see there's a little bit of sun coming in through there and through this window here. If I go to about noon, the sun is overhead, okay? And this is July, so it's right in the summer. And if I go, say, 3 o'clock, then sun is coming in from here. Now, if you had one system doing this entire flow plate, then you can see here in the afternoon, these areas would receive direct sunlight. They would be quite warm. They would need a lot of cooling, right? The center zone won't. It needs cooling, but not as much as what you require in the perimeter zones. So how do you size it? If you size an average, then when you need cooling here, you're not going to get enough, but you might make the internal zone too cold. So everybody's uncomfortable all of the time. So to avoid that, we have this concept called perimeter and internal zones. But when you divide the zones, there is no physical partition. So we use a virtual partition to do that. Okay, that's why this whole exercise of trying to explain it to you. So back to where we were. I am dealing with a conditioned building today. So here's my block. And what I'm going to do is I'm going to break up some more of these zones into perimeter zones. Okay. So to do that, take my partition tool, but instead of a standard partition, I use some virtual partitions. And what I can do is maybe one over there. So now I've got zones here, and I can make as many as I like. And what I've done is I've got my colleague to draw the zones in my DXF file, so it's easy for me to do the drawing. Otherwise, I'd have to draw some construction lines and figure out where everything is. So here's my zone, right? You can see here, I've now got 7 zones. Okay, and I can size equipment or systems to do each of these zones. Now, if you want to make zones, if you're not interested in making such small zones, you can always remove partitions that you don't want, okay? So, for example, if I decide that I really don't need this partition, and maybe this partition, so I've just deleted them. So I get less zones, which means a somewhat less expensive system. But it's still not optimal for these two because they have 2 orientations in there. But we'll leave it at that. Okay. Now, I just wanted to show you that so we can quickly get up to speed here. What I'd like you to do is, before you make any runs, if you look at that PDF sheet called the first model, your first model, that actually gives you a series of things that you should do before you run your first model. Okay. And we're going to do some of them. But what I wanted to do was I want to change some of the defaults so that we start to get proper outcomes. So if you look at these model data input options, we're going to follow that right now. Okay. So I'm just going to set it up so that when we do the run, we start to get numbers that start to make some sense. So let's just follow through. You can read this and watch me. There is a function here which looks like a spanner, which is model options, and that allows you to change design builder's performance for the model you're working on. Okay, so we open that up, and I'm going to just change some default settings. Okay, so if I go to this advanced tab, I'm going to remove this lump similar window surface. And that was kind of built when computers were expensive and memory was expensive. So the idea is that you can put one window on the wall, and if you got exactly identical windows along that wall, you just model one and you multiply by the number of windows. And that's no longer required. And of course, many buildings don't have that, so it's always better to get rid of that straight away. Now, if you go to the simulation tab, there's a few things to change here. We want the time steps per hour. So the number of times Design Builder Energy Plus calculates this, you want it to be 1 every 10 minutes. Now that's a kind of balance between speed and accuracy. Okay, you can have more, takes more time, but I think this is good enough. Back to data. Some representation of the types of data is pretty useful. So how do you decide how to enter the number of people in a space? And one way is you can either say the number of people, or you can say approximately so many meters squared per person. And there are design criteria available everywhere in the world. So we're going to use this area per person. Then power density is good for equipment, but this is so many watts per meter squared per 100 lux. That's the lighting load. So what I'm going to do is to just change it to power density. So it's watts per meter squared. And you can look that up in India, there's ECBC, NBC, all these Griha, all these have got values for these sorts of internal nodes. If we can do that much, we're pretty much ready to run. And say yes, okay on that. So if you go to this activity tab, you can then see that this allows you to specify at the building level these outcomes. Okay, and we'll go through them a little bit more in detail if we have time. But I can say I want 10 meters squared per person. That's a value here. I think in India it's a bit less. You have 8 meters squared per person, so on. Then there's a schedule for how the building is occupied as a profile of how people come in and leave. There's something about metabolic rates. How much heat are you producing? There's something about what kind of clothes are you wearing? What's the air velocity in the room? Typically, if it's an air-conditioned room, there's barely any air velocity, and I think the default is 0.137 meters per second. That's definitely something taken from the old imperial system. There are some heating and cooling set points. So if we say that, okay, heating is only up to 20 degrees, and cooling is up to 24, then you can put that in there. Okay. If you want humidity control in your air conditioning system, you can put the correct numbers in there. There's something here called ventilation set point. I'd like you to remove that. It's a very British thing. The software is built in Britain. Many times their outside air is colder than their inside air, so they just allow the air to come in. Minimum fresh air, again, air conditioning parlance. People who are doing air conditioning know this is outside air, or sometimes called fresh air. Outside air is probably better. And then this one is plug loads. Okay. Now there are a few ways of putting in plug loads. There's not any difference between any of them except in the catering load, because in the catering load you can actually specify what is the latent fraction, how much is humidity coming in the air. Now, unless you've got a kitchen or something, maybe don't worry about it. Give the other loads, because the moisture loads from the air and from the people will get looked after at the system level. Okay, I won't go any deeper right now. There's constructions, there's all kinds of other things. But just by doing that much basic, because I've put it at the building level, it sort of goes all the way down, flows down the data tree. So you can see here, this zone, which is the zone 1, everything's in blue, and it is taking the default from the level above. Okay, so if you go anywhere, you should be able to see things that we chose. Now this ground floor is unconditioned, and it's not really a standard zone. Okay, so what we can do is, there's two options. Either we can switch off everything, or we can call it a semi-exterior unconditioned zone. And I'll show that to you in a second as well. So it removes all these air conditioning bits and pieces from that zone. So at that point, now I don't know anything about construction, I don't know about the glazing, I don't know how the building operates. We'll check all of those out. But I want to just do an energy simulation so you can start exploring the software. Okay. So I'm back at the building level up here. I'll go to the simulation tab. And then I will choose to run a simulation. Okay. Now I can do annual simulation, summer design week, all these, or I can give my own time. What I want to be able to do is to run an hourly output. I don't necessarily want a daily output. I want hourly and monthly outputs. There are some options. We have dealt with some of them already. Okay, and here is where you start to tell it what to report. Okay, so I'm just going to tick a few boxes, but it'll start to give you an idea of what's possible. Okay, I want PMV, I want temperature distribution, and I'm going to ask it for all periods. Oops, sorry. Okay. And I'm not going to ask it to store any outputs at this point, none of the other bits. But in the summary reports, I might ask for zone cooling summary, zone heating summary. And if there were others that I was interested in, I could have. But none of the mechanical system reports are useful at this stage because we haven't defined the mechanical system as yet. We're using a simple ideal system. Okay. So it will now go away and do the run. I pressed OK. And if the weather file is not there in my computer, it'll ask my permission, download the weather data, unzip it, get it in the right place, start the simulation. So it's a very simple building to run pretty quick. Okay. Now, once it's finished the annual simulation, it will then try to load the files, which are Energy Plus files generated by Design Builder. and put them into a display format. Okay, so does that. If I didn't want to use Design Builder as the interface for the output, then I needn't wait for it to load the results. And what you'll find is that in many cases, the energy simulation time itself might be quite small, but loading the data back into the energy simulation, the Design Builder interface is quite time consuming, like you are seeing here. So I'll show you a way of looking at the results without having to look at the results in the interface. But for the present, I'm just asking it to load it. We'll have a quick look at it, and we'll go from there. So, as I said, model, we know just the geometry form. We don't know the construction. We don't know what glazing type. We don't know the lighting systems. We don't know the air conditioning systems. We don't know how it's used, but we are running a simulation. Okay. And hopefully it's just about finished loading everything up, and we'll get some results on the screen. If there are questions you have, please put them on the chat. We can address them as we go along. Okay. Okay, if it doesn't load now, we'll do something. Right, okay. Now you don't see any results, and that's because I didn't generate any daily outputs. I did generate hourly outputs. If I click it to hourly, then it should load the results that it just generated. Okay, here you go. The timestamp for me is 4:19. Just remember that. So it plots a number of results. You can look it up. There are, things that you can do with it. There is other things you can look at, because it's looking to give you advice all the time. So it's telling you where to look for different bits. Okay. Now, for example, instead of all, I could ask it for just the comfort variables, okay, or comfort outcomes, really, not so much variables. So it picks out air temperature, radiant temperature, operative temperature, outside airwork temperature. Don't worry about these. The yellow is the Fanger PMV calculation, and that's pretty high. You wouldn't see that. Relative humidity is also fairly high, and sometimes, other times it's pretty okay. This one is the Fanger calculation for PMV, and you can see that it's varying up and down. These two spikes are probably Saturdays and Sundays, and I'm fairly sure the HVAC system's not working on the weekends. So you can play around. There's a whole bunch of things you can look at, and you can try it out, and you'll get the answers in different scales. So we've done hourly, and we've done for the run period, and I think we've also done monthly. Okay, so you can have a look at that. Right? So that's your kind of very first run. As I said, you don't know too much about the model, but it has given some results. Okay. Now, I told you that there are ways other than using Design Builder to look at the results. So what you can do is you can go to the File, Folders, Energy Plus folder, and these are the standard names of results that it produces. Okay. So if you look at the timestamp, you remember I said if you look at the timestamp, so this is all today's run files. 416, 417, 419. Okay, it's when we started writing the input files and then did the simulation, wrote out the result files. Okay, so two ways to look at the results. One is to look at an HTML file that Energy Plus creates. Now, why do I keep saying Energy Plus Design Builder? That's because, and here's a link for you. Yeah, so if you go to this link, which is simply designbuilder.com.au, that's the Australian website, it explains what Design Builder is, and there's a small video that you can look at how the graphical user interface works. But basically, Design Builder as a graphical user interface has got a series of calculation engines underneath the hood. Okay, Energy Plus is the US DOE, US Department of Energy, developed energy simulation engine. If you've heard of eQuest or DO2, that's the previous generation of software that US DOE produced. Okay, and this is their latest piece of software. It's, I believe, their third generation software, and they're already beginning to work on their fourth. Energy Plus is free. You can download it and directly from the web, and it'll give you, there's 2,500 pages of input data, another 2,000 page manual on all the engineering algorithms. You can go and look at all of that. Okay, but what it is quite difficult to use because it's fairly text based, and that's where Design Builder comes into the picture and allows you to create geometry, very flexible geometry, and then more complicated air conditioning systems and so on. Now, the nice thing about Energy Plus is that it does both heat and mass balance calculations at the same time. And because of that, you can do free floating simulation. So if you don't need a heating and cooling system, you can just open the windows and it predicts what the temperatures will be, which is not as simple as it sounds. I've given you some more things. Energy Plus has got the ASHRAE heat balance equations for cooling load calculations. That's the latest around. There is a interface for developing detailed HVAC. If you guys are interested in that, please put a message in the chat. We can go there. We've seen the visualization engine with sun penetration, sun path diagrams. That's quite visually useful, particularly when you've got other buildings around it, shading it, so you can then work out how your building is impacted by the surrounding buildings. There is an engine called Radiance. It does all the daylighting calculations. So if you're interested in daylighting, this is an easy way to access the Radiance engine outcomes. There's a proprietary CFD engine, which allows computational fluid dynamics analysis, specifically for buildings, in between buildings, inside the building, and so on. Okay, so you're using that now. We're working on it, so we'll go back there. Okay. Now, as I said, you have the option of looking at results in more than that one way. So if I go back to the folders, oops, sorry, here we are. Go to the Energy Plus folder. If I open this HTML file, you can see that it says E+. That's Energy Plus. This is table HTML. So here's the standard HTML output file. and tells you where you ran the file, okay, and tells you that it's a full year's run, and then starts to give you all kinds of numbers, okay. So if you look here, there's no electricity or gas under the heating and cooling numbers. There is electricity for lighting, there is electricity for plug loads, okay. But instead, there are some numbers here for cooling and heating. And these are numbers which are thermal energy numbers, because when we do an ideal system or a simple system in Energy Plus, it doesn't really model compressors and fans and pumps and so on. It just tells you what is the heat load that needs to be extracted or added to that space to keep that building or that space comfortable, okay? And then there's a whole bunch of other things. You can explore them. If you click on the table of contents, you can see all the things that it reports, and you can look them up and see what's going on. We had asked for some cooling summaries. It'll give you that. So depending on which zone you go to, you can see what it's giving you. Okay, similarly for heating as well. Okay, so those are the kinds of results you can get. There is a whole bunch of other things you can look at, try out some of them and see what are things that you might be interested in. Now that's one set of results. If I go back there, there is a CSV file just on top of this. That's got exactly the same data as the HTML file, except it's in CSV format, so you can pick it up in a spreadsheet and you can do further analysis if you needed to. Now, this is another one. Okay, this is a Energy Plus output ESO, Energy Plus standard output file. Okay. Now, if you open it up in a text editor, it's a mass of text numbers. It's really writing 8,760 values of many variables. Okay. But if you download this piece of software, which I gave you in that folder, the one that's called Results Viewer, then that actually allows you to open this ESO file. And then you can start looking at hourly outputs. Okay, and you can look at a bunch of hourly outputs quite usefully. So if you have only done one run, then you can do that full HTML file that you were looking at earlier with me, that's here. Plus on this tab, getting these hourly outputs. So for example, the thermal cooling required for the building to maintain it between 20 and 24 across the year. You can stretch and have a look at how many day you want. For example, if I pull it for just a day, I can even see how it's varying. So obviously there seems to be some sort of a remaining peak from yesterday. So cooling comes on, stops, then waits and goes back up again. Okay, so January, July, October, so on. If I plot district heating, then if there was heating, they would have appeared over here. It seems the combination of materials we have, there doesn't seem to be much heating, so I'm going to delete that. You can plot things that are in the weather file. These environmental variables are from the weather file. You can plot any of those. So for example, outdoor April outdoor airborne temperature, which is really DBD temperature of the weather file. So this will give you what Bangalore temperatures are like. Okay. I should probably put that into a different graph because they're on two different scales. Yeah, here we go. So temperature scale, kilowatt hour scales. Okay, and you can see how temperatures vary in Bangalore. There seems to be a very large diurnal range. 10 degrees, 11 degrees, 12 degrees. And you can see that across the year. Okay. Other things that might be useful for you to look at are there are mean air temperatures, mean radiant temperatures, operative temperatures, which operative temperatures are average of the dry bulb temperature, this one, mean air temperature and the radiant temperature. So if I pick one of the zones, and really I should rename the zones so they make sense, but I won't worry about it for now. Let's pick that zone, zone number 2, which is your, no, not north facing zone is probably not the right one. Let's take one more of these. What is this zone? This zone 4. So it's got a bit of south, which has sun. It's got a bit of west, which has also got sun. So what's happening in the north zone? Okay, so we look at that. Zone 4. Here we are. And if I plot that, then it will plot for me the temperatures. Now, this is when I know my air conditioning is working. Why? Because during that time, the temperature is flat. That's what the air conditioner is designed to do. So comes on, holds the building flat within an hour, just over an hour, and until it's switched off, it keeps the air temperature at 25 degrees centigrade. But the air temperature is not sufficient. If you look at the radiant temperature, then that is what you perceive. And you can see here that temperature is quite higher than the 24. The thermometer says it's 24 degrees centigrade, but because this is a very poor fabric, it says, well, maybe 24 degrees air temperature, but what people are feeling is 34 degrees centigrade. And typically we use a number somewhere in between, and that's really what sorry, that's outdoor temperatures. Outdoor mean air, sorry, radiant temperature. Here we go. So zone 1, plotted it on the wrong graph. That's why. Take that off. And if it's in yellow, I see it. So I'll plot something I don't need in yellow. Yeah, we'll just leave it there. That's the dew point temperature. I don't really need that. But let me find the radiant temperature. Okay, there we are. Air temperature, radiant temperature. So you can see the radiant temperature is much closer to the outside temperature. That means that this fabric is not really high performance. It's not mitigating the radiant temperature to be closer to the air temperature. So now you can go ahead and change the constructions, etc., so that you get a better outcome. Okay, so that's probably a very good quick introduction into how you can start using the program to start looking at building fabric loads. Okay, now Design Builder or Energy Plus is really quite strong, and you can do many other things. So you can look at constructions, right? And you have these definitions for constructions. If you go to the help file, which is online, you can just Google for design builder help, and this is version 7, so all online. You can search, everything is available online. Okay, now if I look for something called combined constructions, then there's a picture there which kind of explains how Design Builder works for constructions, right? It uses these names. There's a ground floor, it's the floor construction for the floor that is connected to the ground. There's an internal floor, there's an external floor. Okay, they're all different, but you can decide what construction to put. There's partition walls, external walls, flat roof, pitched roof, and pitched roof unoccupied, which means there's an attic space here and a ceiling there. You can have pitched roof with occupied, then you don't have a ceiling, and it just becomes that. Okay, so the way you do it in Design Builder is that you just define those constructions here. Design Builder actually figures out which is an external wall, which is a ground floor, which is an internal floor, and applies them there. So it's reasonably intelligent in the way it does that. So if I pick this project wall, you can actually examine that. That's the edit button there. And you can see what it's made of. Brickwork, insulation, concrete block, gypsum plaster. You can change, make any changes you want. Now, it's easy enough. You can add layers, remove layers, add materials. If you pick any of these materials, you will see that there is those materials come with all the physics behind it, right? So conductivity, specific heat, density, surface properties of different kinds, daylight calculation properties, embodied carbon, phase change. But those are sort of UK specific, so be careful, right? And how it's represented. Now, wherever you want, if you don't find a material that you want or a construction you want, the easiest way is you just make a copy and then you edit the copy and then you rename the copy and then you just work on that. So if I said that this is an IIT brickwork and I wanted to change any of these numbers, easy enough. Once you've saved it, you can use that. Okay. So there's quite a lot of detail available for you on that. You can just make sure that you've got everything in the right order from outside to inside. You can work out what is the U value, R value, etc., and go from there. Okay, so that's construction, and there's a lot more, but I'm sort of just very quickly going through that with you. And of course, you don't need to put the same construction everywhere. You can apply it at the building level. The most common construction you can apply at the building level. Then you can go to any zone, any wall itself, and apply a different kind of construction. Okay, so that's probably a good place to have a break. Okay, I'll do windows as well, and then we can have a break and ask some questions. So the way windows work, again, there's something called a glazing type, which is where the performance of the window is described. And the performance of the window, if you know your building physics, is really, you're looking at 3 values, okay? And those three values are the U value, the solar heat gain coefficient, and the light transmission. These are the three performance numbers you want. So you can choose it by, excuse me, we can choose it by choosing lots of products, but in the beginning it's probably easier to just use a simple construction and use the three values. Adjust the three values as you see fit. Okay, again, same thing. You can apply different constructions anywhere. Excuse me, I'm going to get a sneeze fit, so I might have a few sneezes. Now, this is where the default window construction is. So you can pick a particular kind of window if it's a regular window. If it's not, you can remove the windows and draw them yourself. So suppose I say no glazing at the building level. Then it removes all the windows. Then you can go to any wall, external wall. There we go. Put it in normal and draw. Excuse me, windows. Now I'm just going to be quite careless about it, but you can be quite accurate in the way you draw windows. Okay. Now if I go back to the building level, I can see my windows. So that'll do windows for you. Okay, I'm going to take a break here and ask for if you have some questions. Any questions, and what are you guys interested in, which I can show you? Please feel free to open up your microphone and ask questions or type on the chat, whichever you prefer.
So I have one question. Like you explained that in summary we can see total cooling load in that cooling load section. But if we install the local HVAC system, like I know my HVAC system had some performance characteristic. Based on that, is it possible to get that value into electricity supply as well?
Okay, so this was what I showed you was mainly about the building fabric. If you want to model an air conditioning system, you can turn on detailed air conditioning, right? And if I turn this up to detail, and there's a huge amount of information. I'm just trying to give you everything very quickly, so I'm sure we won't be able to cover everything and many things. But when you do that, you actually then get an HVAC system to draw. Okay, and within the HVAC system, you get many different templates of systems. So you can pick a template, and then from that template, you can start to construct your own air conditioning system. So let me just say, this is a very theoretical system because on this small size of building, you are not going to use a chilled water system. But Now I have a chiller, a cooling tower. This chiller serves an AHU. AHU's got a cooling coil and a heating coil, supply fan. Sorry?
Sorry to interrupt.
Mm.
Screen is not shared if you are showing some.
Hang on. I do apologize. How's that?
Yeah, it's visible.
Let me do it again because you would have missed that. See, what I did was at the building, I chose this. When I started, the model was having simple HVAC. So at simple HVAC, if you look at the building tree, it doesn't have an HVAC system here. If I switch it to detailed HVAC, okay, and then what happens is it gives me a HVAC system drawing pane, a separate graphic user interface. I can load a series of HVAC types. Okay, so I can load this VAV with reheat water cooled chiller option, and you can load something that is close to what you want, and then you can modify it. Okay, so here, if I remove that unconditioned zone, so I get a sort of pre-set up air conditioning system, which you can then adjust. So I have one chiller, one AHU, one cooling tower that supplies the cooling coil in the AHU. AHU's got supply fan, return fan, controller. And these are all energy plus objects. Chiller has got its pump controller. So supply header, return header. Cooling tower has got supply header, return header, pump, and a set point manager controller, right? Similarly for boiler, the boiler producing hot water supplies this coil, pump, so on. Okay, and this is now a zone group, and the zone group has got all the zones that are being air conditioned. In each zone, right now, I have a VAV box with a reheat coil, and I have many options here. So I can choose whatever terminal unit I want. Then, and again, I won't, I'm going to leave everything as defaults, but you should really go and examine each one. You can keep digging into it at different levels, so you can go and look at each of these pieces of kit, and you can continue to make changes. Okay, make sure that you've got the correct parameters there. So it's quite detailed. And also, if you look at it, it comes in loops. So there's a chill water loop. The chilled water loop has a demand side, what is demanding chilled water, and you have a supply side, what is supplying chilled water. So in the supply side, there's a chiller, the pump, the controller. And similarly, there's air loop for the AHU side. Sorry. Okay. And again, there's a demand side, which is the zone, and there's a supply side, which is the AHU. And then again, within that, you can keep double clicking and going down as far as you want. And each of these components you can examine, and you can make modifications to all of that. All of this is energy plus. Okay. Now, if I rerun that simulation, and obviously, as I said, you won't make a chill water system for such a small building. You might have a VRF for a window air conditioner, PTAC, they call it. But if I run this simulation, now it will give me electricity. It will give me fan, pump, all those numbers, cooling tower, heat rejection numbers, boiler numbers. It'll give me all of those numbers. Okay. So there's a huge amount of detail, and as you learn more and more, you get used to doing better models. So that the PDF that I gave you about your first model, really we're talking more fabric, but it gives you an order of how to do that. My suggestion is that if you guys go off and try it for a couple of weeks, you may have more questions. Then we can do a second session where hopefully I can try to answer some more questions. I'll put some links on videos that we've run for Solar Decathlon India. I've done about 6 serial webinars, and that will takes you step by step through many of the processes we've talked about. Okay, so I will cancel that, but I will go to the results. And if I go to the HTML file, and if I look at those numbers again, now you'll see heating, cooling. So this is a chiller number. This is the AHU fan number. These are the pumps. This is the cooling tower. So nothing here. It's now all electricity and gas. Okay. So that's the way you would go about it. And if you opened up that the new ESO file, I'll close the old one and go to the same place, then you can actually plot those things. So you can see how the chiller energy used, the cooling tower energy used, the fan energy used, how they all vary. Again, I haven't looked in detail, so I don't know if it's VSD or constant flow or what is the COP or all of those things, but you can see how they are available to you. So chiller electricity rate, chiller cooling rate. So this is thermal, this is electricity. Okay, so you can see how, depending on the COP, you can see how that varies. Okay, and of course, cooling tower, fan energy, thermal energy. They'll be the same for AHU fans, supply fan, extract fan, cooling tower. Everything will be available to you, and all these numbers will be available in the HTML file as well. I don't know if I actually asked it to write those. No, I haven't, but you can in the options part. So let me just rerun it one more time. In this output section, there are summary tables, monthly reports, and I can ask for chiller report, tower report, boiler report, fan report, pump report, and so many other things, right? So if I rerun this, it will actually give me those electricity numbers by month. So it's quite powerful, it's quite detailed, and if you know your HVAC system and if you know your building physics, you can get some really powerful outcomes from it. The other thing you can do is you can run 2 runs and you can compare the runs for 2 runs and see the impact of your changes. Okay, I'll show you how to do that in a minute. So while it's, okay, let me cancel the run, go to the results. HTML file. I'll close the old one. And if I look at the table of contents, now you can see it. Chiller report, tower report, boiler report, fan report, pump report. So if I look at the chiller, yeah, there we go. So energy use, maximum chiller demand, when that happened, how many hours did it run, etc., etc., etc. Okay. So there's quite a lot of information available for you. Right. One last thing before we close off, and that is, how do you compare two sets of runs, right? Now, what happens is that every time Energy Plus runs, it overwrites these standard files, okay? Because you get the same name files. So the easiest thing is to just copy these files. I'm going to copy these 3 because I want them, and put it somewhere. Let me put it, okay, I'll put a new folder. I'll just call it IIT. And let me just call this run 0. This is our base case, so I'm going to call it run 0. Then let me make a change. Okay, so what I'll do, okay, so something to make a quick impact on it. We don't have many windows, so I'm going to do a little trick. Okay. Oh, just matter. I'm going to drag that up by about 1 meter. Then I'm going to draw one more block, and this time I'm going to draw a component block, which is a shading device, and draw it on this. And the color of this shading device will be a slightly different color. It's usually pink type color. Okay. Now I'm going to delete this block. So what I've created is a shading device which is floating in the air. Now I don't need to model the structure. My impact here is, how does it control the sun? Right? The roof is the one that gives the highest cooling load. So all I've done is created a big shading device. You can see here that the roof is mainly shaded, right? Now, I expect that if I do this, my cooling load should come down. So if I do a second run, then if I then look at the cooling energy use, hopefully that's come down a bit. And I just look at the chiller energy use, and then if you want, we can compare the two thermal loads for cooling between our run 0, and I'll call this run 1. Now, I'm sorry, I'm sort of rushing. There's a lot of stuff, and I'm just sort of skimming the edges. Typically, we take a 2-day workshop to cover the entire, well, as much as possible. So here we go. Result. Energy plus folder. What I'll do is copy these these three files, put it into my same folder. Rename that. So I'll call this run 1. Okay. Now, so the first thing that you can do is very quickly is just look at the HTML files. So if you look at this is run 0, energy used for cooling is 39,632 kilowatt hours. And for run 1, is 34,707. So we have dropped it by about 5,000 kilowatt hours. Okay, so 5 on 40 is what is that? One. My maths is getting on me now. We've reduced it by a reasonable percentage. Okay, so about 5,000 out of 40,000. We have reduced it by. So when did we reduce it by is an interesting one to look at, which we look at by comparing. About 12-13% we have lowered it by, and that we can compare by looking at this ESO file, this output file. So I load the results for the first run, if you wish, and you can see here these are the plots numbers here. But what I'll also do is at the same point, I will open this, add in this second data set. Okay, so this limitation is only based on your computer's RAM and how fast it is. So you can have multiple results open and you can compare it, but more than 2 or 3, your computer starts to struggle, because for big buildings there's quite a lot of data. So now I've got run 0 and I've got run 1 results plotted on the same, lifted in the same environment. And if I compare the thermal loads, actually let me do this differently. If I plot both of those, then you can see the difference between by shading the, that difference in cooling load is because of the intervention I did on the building fabric. Okay, and you can of course try so many things: window performance, shading performance, HVAC system energy efficiency, different kind of HVAC system, all of those things. Okay, how's that? Can we do a QA session?
Yeah, sure.
Questions? How many of you are HVAC engineers, air conditioning? How many of you are architects? Or others, PV systems? Okay, I can see somebody who's HVAC engineer. What about the others? Come on, you turn on your camera and interact. This is very boring if you don't do that.
I think most of us are also juniors, like they are starting their career in engineering or energy engineering. So they can put as well, like energy, as Prabhat mentioned.
Okay, that's okay. Don't hesitate to ask. There is a lot to learn. Okay, some energy engineers are there, good. There's some more HVAC engineers. That's very good. Yeah, don't hesitate to ask. This is, like I said, we are. It is. I'm trying to do a lot in a very short amount of time, and there's probably not enough. Let me, since you guys are starting, let me do one thing. Let me just see if I can give you some links here. Hang on, hold on. Okay. So there is, I'm going to put here in the YouTube, sorry, in the chat box. Sorry, I do apologize. I will send it. And Josh, if you can circulate, that'll probably be better. So these are webinars that we ran for the Solar Decathlon India team. They will generally be somebody else who talks about the theory of building physics, and then there will be, I will do an hour to hour and a half on these subjects. So my suggestion is that you can work through these 6 webinars, and you will have learned quite a lot. Okay, and then if you come back and we have a Q&A session, then you come prepared with questions. You work on some model that you like, and then we can have meaningful discussion. Because right now, I think you're just trying to understand what's possible with the software. There's a lot possible. It's quite huge, you know. And I encourage you also to go and look up these hang on, look up things like, you know, Energy Plus, which is the energy simulation engine which we were talking about. So you get an idea of what's underneath design builder, how good energy design builder. So you can look up about Energy Plus. You can look up the links that I've given you on the not this one, the other one, designbuilder.com.au. Oh, probably I should write it out. So design builder. Oops, sorry, typing is not very good. And in there, you can actually look at the links that I've got posted there. So what is Design Builder? This is a good one to look at. Read this text that I've given you. I've given you some links over there. If you go to the support and training page, there's a, right at the bottom, there's a couple of that video about that energy simulation analysis part is there. You can have a look at that. I think between those things, there's quite a lot of outcome that you can work out from there. There is maybe one more video that probably is useful. Those of you who are interested in maybe looking at more passive type passive type opportunities. There's another link at the bottom of that. So that's another lecture that I've given, which is more of passive type opportunity. So the ones above that are all the webinars that we have conducted. So you will get a lot of training by doing all those, just working your way through those videos. Okay. And then, as I said, if you want to have a second session where we can do some interactive Q&A type thing, I'm very happy to do that.
Can I have a question?
Sure.
Yeah, so like it's regarding the previous question, continuation of the previous question, like the chilled water system.
Mhm.
We can incorporate the chilled water system from the design, but if we want to have a radiant panel in our, like a wall mounted radiant panel in our house, how can we do that in the design builder? Because design builder has that chilled ceiling thing in its options, but like wall mounted radiant panels I can't see. So can we do that in design builder, or
You
what?
can
Hmm.
radiant radiant cooling. Somebody or the other always has done something and put up something on the, here you go. So if you look it up, you'll pretty much find it. There's this is a YouTube link for that. There is also some in the help as well. There is. Okay.
But
So
these things are, they put up pipes in the ceiling itself, and then they model it. But if we want a panel in the wall, like including a surface in the wall and pipes going through that panel, and then we want to model it. Like these are chilled ceiling thing. We need a, if we want to model a panels in wall panels, then like I can't find that.
yeah, really what you're looking for is passive chill beams at that point. Okay. So passive chill beams basically just you circulate chilled water through panels at the ceiling, and that's what you call radiant cooling in India. So that's available as well. There's active chill beams, there's passive chill beams, there's underfloor air conditioning, there's VAV systems. Many of those are available, but essentially you need to know how to design them. Once you design them, you can model them in Design Builder. Design Builder is not a it's not a design tool for air conditioning system. It's an energy modeling tool in which you can put a system in there. So you can't really do, well, you can, but you have to actively work on it. You can size things. So within Design Builder, for example, if you go to the cooling design, right, and one of those webinars, this one, I have addressed that, how to do load calculations. You can set design conditions at the location level. So your summer design data you can choose, and there are options that you have to understand which options to choose. And then you can run a cooling design as long as you've got all your internal loads set, your thermostats are correctly set, all of those things are done. You can actually run a cooling design calculation. I'll change the oversizing factor to 1. And June, okay, let me do April to September. So then it goes away and it calculates loads, and then it tells you what the loads are. And then you can get coincident loads and non-coincident loads for some of the peaks and so on, right? So this is the summary, but if I mean, sorry, this is the graph, but if I go to the summary, then I can look at, this is each zone peaking at different times. And then this is when the building is peaking at one time. What is the load? So a coincident peak, a non-coincident peak for each zone, that's all available. You can see what you can get, your flow rates, you can get your cooling load, sensible and latent. You can see whether it's achieved the temperature that you were trying to, what is the humidity at that point. And it gives you check figures, liters per second per meter squared, watts per meter squared for cooling. What is the outside temperature in the data file? How much gain you're getting from each of those components? What is the fresh air percentage as a percentage of supply air? So it gives you quite a lot of information as long as you know how to use it. Okay. Radiant cooling is available. I'm sure there was a, I think there was this a Swiss development company in India, I forgot, BWE something it was. They had done a full they'd done a full lecture on how to do radiant cooling systems in design builder, because I think in Hyderabad they are quite popular. Radiant cooling is quite popular in Hyderabad. One of your IT companies uses a lot of radiant cooling. Infosys, I think, there's a lot of radiant cooling systems. So they had done quite a elaborate training seminar on that. I'll try and see if I can find it, and then share it with you if you're interested.
Okay. One more question, like once we start drawing the external walls, we draw a line, but actually it comes as a thickness there.
Correct.
So should we, like, that line which we draw is the internal surface of that wall or the external one?
Okay. So again, as you learn about it, it gets more complicated in the sense that you have got these, in the construction tab, you have these conventions. So the default convention is that you draw the external wall for the footprint of the building, and then for the partitions you draw the center line. Okay, and then what it does is that it works out, depending on what construction you have given it, it works out what is the internal area, uses that for calculating the areas and the volumes, but the external wall surface is correctly represented. Okay, but you can change that. You have a number of different options available in the help file. If you read it, you can find it. And always kind of remember, this is not a CAD file. This is a physics model. Sometimes the picture representation is not what you're interested in. You're interested in how is the building physics represented, or how is the HVAC system or the electric lighting system or whatever it is that you're modeling, how is that represented? Is that correctly represented or not? I don't know if that makes sense, but hopefully that does. Okay.
Yeah. Like, yeah, I understood the point.
Good. Anyone else? Okay, if nobody else has questions, we can close it off.
Yeah, I think so. Josh, are you here?
Yes,
Yeah.
I'm there.
you can take.
Yeah. Everyone, I'm just sending a form for feedback and for the certificates. So just fill the form. Certificates will be sent only through those. And you can put your doubts in the chat box. And even if you have doubts later on, you can put us via mail or text on the number, and then we'll get back to you.
Yeah, if you have queries, you coordinate it through Jash. My suggestion is maybe after 2 weeks, you can collect all the queries that you might have, and we can just run one session. Is that okay, Jash?
Yes, sir. And I'd like to thank you so much for a wonderful session. It was very detailed and precise. So I personally had used basic design builder for quite some time, but it was very difficult for me to use, and I think it will be easy for me now. So thank you for the session, and hope seeing you later on also.
Wonderful. Thank you so much.